There are four main forces in the universe, which are electromagnetic force, strong nuclear force, weak nuclear force, and gravitational force. It is because of these forces that the universe exists in this form. The force that will be focused on this project is gravitational force as created by Newton and explain the paradox involved in. We have three main goals of this project. The first one is understanding the motion of center of mass. And the second one is that determining the influence of the angle of inclination of the bases on the time of rolling and the conditions under which the body will be motionless. And the other is that explain the anti-gravity paradox of the double cone motion. Now let's continue with our mechanism. Project is a simple setup with two funnels which are filled with styrofoam inside instead of two cones, and wooden sticks attached to boxes with tape. Thus, it was possible to observe the angle changes to the desired extent. For making this experiment, the motion was observed by changing the angles at two different slope values. Slope values found are as follows in Figure 1 and Figure 2. In this part, the most important question was whether an upward movement could be achieved on two different slopes and how the critical angle value would change in this case. Many trials were made to reach the critical point, which was in the steady form. Then, measurements were made on how the two different slopes angle would affect the angle values between the wood sticks. Now let's continue with watching these trials. When we set up a mechanism with 6-degree slope, we determined the angle required for the cone to move downward, the angle required for the cone to move upward, and the critical angle value, which was the angle required for the cone didn't move. When we found our critical angle, the cone didn't move even though we left the cone from three different places. In the experiment, we repeated what we did in previous experiment with 9 degrees of incline. The angle values that we determined through these experiments are shown in the graph below. When examining the graph, something was noticed that when reaching critical angle value is as follows. One of them is that while an upward movement is observed at an angle value less than the critical angle value, a downward movement towards gravity is observed at angles larger than the critical angle value. As a result of our experiment, our conclusion was as follows. At the critical point, no matter where an object was placed, it remained constant in its place. Furthermore, the motion of the funnels at a certain value below the critical angle was unexpected. Contrary to expectation, it didn't move in the direction of gravity, but instead made an upward movement. In this paradox, there is a station that seemed to be against gravity, but it turned out that the station can be explained according to the laws of physics. It is known that objects move in direction of their center of mass, and this is an element that changes according to the shape of our object, and a body in the presence of the gravitational force moves towards a minimum of the gravitational potential energy. Although the cone we used in the experiment seems to move against gravity, it moves in the direction of its center of mass. When looking at the double cone, the center of mass will not rise when the entire body seems to move upward. In fact, it moves downward due to divergence in rails. It can be said that the center of gravity decreases as the distance from the horizontal plane increases. The phenomenon is in accordance with Newton's law of mechanics, which describe how physical objects interact with one another. Thanks for watching our presentation.